Hello friends, in this video we are going to solve some integral using beta function. So first example is integration 0 to 1 x raised to m 1 minus x raised to n raised to p dx. So here we see that there is a term 1 minus x raised to n. So we will put x raised to n equal to t, that is x equal to t raised to 1 by n. So on differentiation we get dx equal to 1 by n t raised to 1 by n minus 1 dt. Also the limits are 0 to 1. So when x is 0, t will be 0, and when x is 1, t will be 1 raised to n, that will be 1. So the limit remains the same. Therefore this integration becomes integration 0 to 1 x raised to m. Now the value of x is t raised to 1 by n. Therefore x raised to m will be t raised to m by n into 1 minus x raised to n raised to p, that is 1 minus t whole raised to p into dx. dx is 1 by n t raised to 1 by n minus 1 dt. Now here the power of t is m by n and here the power of t is 1 by n minus 1. Therefore the power of t will be m plus 1 by n minus 1, and this term will remain as it is, 1 minus t raised to p, and we have taken this 1 by n outside. So this integral becomes 1 by n integration 0 to 1 t raised to m plus 1 minus 1 m plus 1 by n minus 1 into 1 minus t raised to p, and this is equal to, now we know that beta of mn, this is equal to integration 0 to 1 x raised to m minus 1 minus x raised to n minus 1 dx. That is, the value of this integral is equal to beta of mn. So applying this definition, the value of this integral will be beta of this term plus 1, that will be m plus 1 by n comma p plus 1. So the value of this integral is equal to 1 by n beta of m plus 1 by n comma p plus 1. Now second example is integration 0 to 1 x raised to 6 into 1 minus x square raised to 1 by 2 dx. So we will put x square equal to t, that is x equal to t raised to 1 by 2, that is dx equal to 1 by 2 t raised to minus 1 by 2 dt. The limit will remain the same. Therefore this integral changes to integration 0 to 1 x raised to 6. Now x is equals to t raised to 1 by 2, so raised to 6, it will become t cube into 1 minus x square raised to 1 by 2, and x square is t, so 1 minus t raised to 1 by 2, and dx is 1 by 2 t raised to minus 1 by 2 dt. So this integral becomes 1 by 2, that is this one, into integration 0 to 1 t raised to 5 by 2, that is here 3 minus 1 by 2, that is 5 by 2, into 1 minus t raised to 1 by 2. So again by definition of beta, this integral is equal to beta of 5 by 2 plus 1 comma 1 by 2 plus 1, that is beta of 7 by 2 comma 3 by 2. Therefore the value of this integral is equal to 1 by 2 beta of 7 by 2 comma 3 by 2. Now okay, again by relation between beta and gamma function, we have beta of m comma n, this is equal to gamma m into gamma n upon gamma of m plus n. So this becomes gamma of 7 by 2 into gamma of 3 by 2 upon gamma of 7 by 2 plus 3 by 2, that is gamma of 5. So if we solve this, we will get 5 pi upon 2 raised to 8, that is gamma 7 by 2, this is going to be 5 by 2, 3 by 2, 1 by 2, gamma 1 by 2, that is square root of pi. Similarly gamma 3 by 2, this is equal to 1 by 2 gamma 1 by 2, that is square root of pi, and gamma 5, this is equal to 4 factorial. So putting these values here, we will get 5 pi upon 2 raised to 8. Now next example is integration 0 to 1 x raised to 5 into bracket 1 minus x cube raised to 10 dx. So we will put x cube equal to t, that is x equal to t raised to 1 by 3. Therefore dx will be 1 by 3 t raised to minus 2 by 3 dt. The limit remains the same. Therefore this integral is equal to integration 0 to 1 x raised to 5. Now x is equal to t raised to 1 by 3. So raised to 5. So it will become t raised to 5 by 3 into 1 minus x cube. X cube is t. So 1 minus t raised to 10 into dx. Dx is 1 by 3 t raised to minus 2 by 3 dt. Now we will take this 1 by 3 outside. So the remaining integral will be integration 0 to 1 t raised to 5 by 3 minus 2 by 3, that is 3 by 3, that is 1. So integration 0 to 1 t 1 minus t raised to 10 dt. Now again by definition of beta, this integral is equal to beta of 2 comma 11. Therefore the value of this integral is 1 by 3 beta of 2 comma 11. Now again by relation between beta and gamma, we have this beta of 2 comma 11, this is equal to gamma of 2 gamma of 11 divided by gamma of 2 plus 11, that is gamma of 30. Now we can reduce this to, now gamma of 2, this is equal to 1 factorial, that is 1, and gamma of 13, this can be written as 12 gamma 12, and again this 12 can be written to gamma 12 can be written as 11 gamma 11. So this gamma 11 and this gamma 11 will cancel. So the remaining answer will be 1 upon 396. So the value of this integral is equal to 1 upon 396. Now next example is integration 0 to 2a x raised to m square root of 2ax minus x square dx. Now we see that here the term is 2ax minus x square. If we take common 2ax, we will get 1 minus x upon 2a, and then if we put x equal to 2at, then this 2a and this 2a will get cancelled and we will get 1 minus t. So we will put x equal to 2at in order to get 1 minus t. So by putting x equal to 2at, we have dx equal to 2a dt. Also the limits here are 0 to 2a. So when x is equal to 0, t will be 0, and when x is equal to 2a, this 2a and this 2a get cancelled, so t will be 1. Therefore this integral reduces to integration 0 to 1 x raised to m. Now the value of x is 280. So 2a raised to m t raised to m into square root of 2ax minus x square. So it will become 2a as it is. The value of x is 280, and we have taken this common. Since 2ax minus x square, this is equal to this term, and we have put x equal to 280, so this reduces to 2a into 280 into bracket 1 minus t and whole raised to 1 by 2, since there is a square root, and dx is equal to 2a dt. Now we see that here 2a into 2a, that is 2a square, and raised to 1 by 2, that is only 2a. Here there is one more term 2a, so 2a square, and here the power of 2a is m. So the power of 2a will be 2a raised to m plus 2. So we will take it common. We will take 2a raised to m plus 2 out. So the remaining integral will be integration 0 to 1 t raised to m plus 1 by 2. So here the power is m, and here the power of t is 1 by 2. So the power of t will be m raised to, power of t will be m plus 1 by 2 into 1 minus t raised to 1 by 2 dt. And now by definition of beta, this integral is equal to beta of m plus 1 by 2 plus 1 comma n plus 1, that is 1 by 2 plus 1. So that is beta of m plus 3 by 2 comma 3 by 2. So the value of this integral is equal to 2a raised to m plus 2 into beta of m plus 3 by 2 comma 3 by 2. Now next example is integration 0 to 4 x square into square root of 4 minus x square dx. So here also we will put x equal to 4t. Since by putting x equal to 4t, this term will reduce to, okay, this term is 4x minus x square, and if we put x equal to 4t, the first term will be 16t minus x square, that is 16t square, and if we take 16t common, we will get 1 minus t. So we will put x equal to 4t, that is dx equal to 4 dt, and 4x minus x square will be 16t into 1 minus t. Also when x is 0, t will be 0, and when x is 4, t will be 1. Therefore this integral will be integration 0 to 1 x square, that is 4t square, that is 16t square, into square root of 4x minus x square. So 4x minus x square is 16t into 1 minus t raised to 1 by 2 into dx. dx is 4 into dt. So we will have this 16 into 16 raised to 1 by 2, that is 4, into this 4, that is 16, into this 16, that is 16 square. So we will take this 256 outside, and the remaining integral will be integration 0 to 1 t raised to 5 by 2, that is this 2 plus 1 by 2. So the power of t will be 5 by 2 into 1 minus t raised to 1 by 2 dt. So by definition of beta, this integral is equal to beta of 5 by 2 plus 1, that is 7 by 2, comma 1 by 2 plus 1, that is 3 by 2. And if we solve this by relation between beta and gamma, that is beta of 7 by 2 comma 3 by 2, this is equal to gamma 7 by 2 gamma 3 by 2 upon gamma of 7 by 2 plus 3 by 2, that is gamma of 5. And again 7 by 2, this is equal to 5 by 2 into 3 by 2 into 1 by 2. Gamma 1 by 2 is square root of pi, and gamma 3 by 2 is 1 by 2. Gamma 1 by 2 is square root of pi divided by gamma 5, that is 4 factorial. So if we solve this and multiply by 256, we will get the answer 10 pi. So the value of this integral is equal to 10 pi. Now next example is integration 0 to 1 minus nth root of x whole raised to m dx. And here the numbers n and m are positive integers. So we will first put nth root of x equal to t. Now nth root of x equal to t, this implies x will be t raised to n. Therefore dx will be n into t raised to n minus 1 dt. Also when x is 0, t will be 0, and when x is 1, nth root of 1 is 1, so t will be 1. So this limit remains the same. Therefore this integral reduces to integration 0 to 1 minus nth root of x, that is 1 minus t raised to m into dx. dx is n into t raised to n minus 1 dt. Since this n is a constant, we will take it out. So the remaining integral will be integration 0 to 1 t raised to n minus 1 minus t raised to m dt. And by definition of beta, this is equal to beta of n minus 1 plus 1, that will be n comma m plus 1. Therefore the value of this integral is equal to n into beta of n comma m plus 1. Now here we have given that m and n are positive integer. So this beta of n comma m plus 1, this can be written as gamma of m plus 1 upon gamma of n plus m plus 1, and since these are positive integers, this gamma n, this is equal to n minus 1 factorial. This gamma m plus 1, this is equal to m factorial, and gamma n plus m plus 1, this is equal to n plus m factorial. Therefore n into n minus 1 factorial, this is equal to n factorial. Therefore this reduces to n factorial into m factorial upon n plus m factorial. We can use this formula since m and n are positive integer. If this is not given that m and n are positive integers, then the answer of this equation, then the answer of this integral will be this one, that is n gamma m plus 1 upon gamma n plus m plus 1.